Implementing transactions. The idea of a transaction, of an atomic unit that we can either commit or roll back that helps us leave a consistent state of our data during a crash, is an important one. In this talk, I will look a little under the hood at how this can work. Kroenke covers this topic a bit in chapters 9 on pages 359, 363. Have a look there if my talk doesn't work for you. So I want to take our basic problem that we saw a couple lectures ago that set up the idea of a transaction. Alice writes Bill a check for $100. We'll assume that Alice and Bill have the same bank account, or the same bank, and Bill deposits the check. The bank will then move $100 from Alice's account to Bill's account. It'll look something like this on a successful case, which is of course typical. So Alice has some balance, let's say it's $500, and Bill has a balance of say $200. So we subtract the value, the amount of the check from Alice minus $100, and we add the check to Bill plus $100. And at the end, Alice's balance is $400, that's down $100. Bill's balance is $300, that's up $100. Okay. And we talked about how this can become a problem if anything gets interrupted in the middle. So what happens under the hood? Well, our pre-transaction idea, we would have something like this. We would have some data file for accounts. And Bill somewhere in that file has his balance recorded. And Alice somewhere in that file has her balance recorded. And we update those two balances, right? And so that's where we are at the end of a successful transaction. So far, so good. But what if we have a crash? So we take Alice's balance of $500, we subtract $100 from it, and things crash before we put the money into Bill's account. At this point, Alice's balance is $400, Bill's balance is $200. Somehow we have $100 gone missing, right? And that creates our problem that we discussed a couple of lectures ago. Under the hood, our data file ends up looking like this, and this is, of course, not where we want to end up. Okay. So enter transactions. We said we looked at transactions at a more logical level and saw how they took care of it. Now we're going to look a little under the hood. And basically for each data file that we had, in this case accounts, we're going to have some other additional files. We're going to have an after image file. And I would note that in the after image file, it's a little different. The data file we're assuming we updated in place, but the after image file we're going to assume is sequential, that new records are put on the end of the after image file. And we get a copy of each record that gets changed, and it goes at the end each time it gets changed. So if we change Alice's balance 3 times, let's say we process 3 checks against her account, we're going to end up with 3 entries in the after image file for Alice's balance, right? One for each time the check is debited against it. Then we also have a file called the before image, and I won't run through this further, but we're going to assume that we have a before image file for each user of the database. So this is really keeping track of things for that particular user, whereas the data file is common for all the users, as is the after image file. So we have a before image, a data file, and an after image. So once again, this is a successful transaction. It's the same as our successful transaction was previously. But when we look at it under the covers, we're going to go through it in a series of steps. Particularly, our first step was we were going to change Alice's balance. Now with transactions, when we start the transaction, we begin transaction, that means that every time we're going to change a record, we're first going to make a copy of it into the before image. So Alice's balance was $500. We're about to subtract $100 from it, but before we do, we'll make a copy of that record into the before image file. Now we change the balance, okay? And next, we write the new version of the record into the after image file, right? Once again, the new records go at the end of the file, and Alice's balance may occur many times in this file, once for each time it was changed during the day. So we've got a change to the data file, we've got an entry in the before image and an entry in the after image. What comes next? Well, next we're going to start changing Bill's balance, but before we change Bill's balance, we're going to make a copy of that record before the change into the before image file. Now we're going to change the balance in the data file. And now we're going to add in a record for the balance to the after image file. And then, let me come back for a second. If things were to go south right now, we could get back to the way things were before we made the changes, because we have a copy of the records before they were changed in the before image file. So this is one of our tools in making this whole thing work. Assuming everything's still good though, and we get to the end of our transaction, we either commit or roll back. So let's look at what a commit looks like. To commit, all we do is we reset the before image file. That's our critical step in a successful transaction. This indicates to us that there's no old images that should be taken into account, that we're completely up to date. And all of the changes that need to be made in this transaction have been made in the data file, so we're good. We can now discard the before images, and we still have our after images in case we need to restore things. We'll talk more about that in a second. Alternately, if we get to the end of the transaction we call rollback, what happens? On rollback, we copy each entry in the before image file over the top of the data file, replacing the data file values. So this is going to restore the Alice record to have a balance of 500, and it's going to restore the Bill record to have a balance of 300. Now the data file will be just as it was right before we started the transaction. And we'll also clear out the after, actually we don't need to clear out the after image records. Well, there are a couple ways you can handle it, but we'll also have to keep an eye on the after image. But we've taken care of our problem of the data file being out of sync with itself. Let's look, that was how a normal rollback looked. Let's look at how a crash works, right? This is our crash scenario, the same one we had a couple of lectures ago, right? We get to the middle of this thing, we've taken the money out of Alice's account, but not put it into Bill's account, we have a crash. Okay, at the time of the crash, the database, because of transactions, now looks like this, okay? You'll notice that we have a before image Alice balance of $500, okay? So what we can do now at the time of the crash to recover from the crash is we can copy that before image back over the top of the data file. So to recover, we're going to read through the after image file, and we're going to write each record on top of the corresponding data file. Then we're going to reset the after image file. After all the after image records have been read and written, we start on the before image file. Each record in each of the before image files, you recall we have one per user, is read and written over the top of the corresponding data file record. Now, if we just do a rollback, we know which user we're doing the rollback for, so we only have to work with one before image file. But if we're recovering from a crash, the crash presumably affected all of our users, and so we're going to make use of all of the before image files, one for each user. At this point, the data file is back to where it was for all the transactions completed before the crash, and it's now safe for us to go back to using the database. So when we're finished recovering, we're back to this point. We've got nothing in the before image, we've got nothing in the after image, and we've got the balances the way they were at the beginning of the transactions that didn't complete. I'll also mention backups at this point. For databases, normally a backup is made once a day, typically to tape. Once the backup is complete, the after image file is reset to be empty. It's safe to do this because we now have the tape backup. If the data file is destroyed at this point, the backup can be combined with the after image to avoid data loss. So suppose we do a backup in the middle of the night, we get to the middle of the day and we have a crash. Well, by restoring the tape and then putting the after image file back on top of the data file, we bring ourselves up to where we were during the day, even though we aren't doing a backup continuously. Traditionally, a system was taken out of service each night while a backup was made. We would actually shut the system down, or more likely disconnect the users, and then the night crew would put a tape on the tape drive, make a copy of the various data files as they were changed during the day, and move them to someplace safe. and then put the system back online where people could access it. Now we expect systems to be up 24/7, 24 hours a day, 7 days a week. So more elaborate schemes are used. But if you don't understand this approach, you're not going to understand the more elaborate schemes, which we're not going to worry about for this course. But this gives you a feel for how transactions work and play with backups to keep us safe from crashes and also allow us to back out of mistakes where we realize we don't want to complete a transaction for a variety of reasons.